On to problem 17 of the MIT Integration Big Qualifying Exam 2017, which is the definite integral from x tending to negative infinity to x tending to positive infinity of 3x squared times x cubed plus 1 squared times e to the minus x to the power 6 minus 2x cubed. So this is an interesting problem, very similar to what you would apply to the problem 16. Let's see how we may be able to solve this. So this is our problem. Integral from x tending to negative infinity to x tending to positive infinity of 3x squared x cubed plus 1 squared e to the minus x the power 6 minus 2x cube. So let me try and see how I may rearrange this problem. I could pull x cube out here so that I have x cube plus 2, right? And then I may be able to take the 3x squared that side so that I can say let u be equal to x cubed, and so du dx is equal to 3x squared, and so du can be used to substitute of 3x squared dx, right? And then the limits would just remain the same. So we have this problem x cubed plus 1 squared ex cubed x cubed plus 2 3x squared dx. So taking it to the u domain, we have u plus 1 squared, and then we have u plus 2 du. And then let's continue. So I have u plus 1 squared u squared plus 2u du. Now I want to focus here a little bit. So we have u plus 1 squared u plus 1 squared minus 1, so that this negative and this negative can interact, this negative and this negative can interact, so that it becomes an e. Let me probably rewrite that a little bit so that u plus 1 squared minus 1 du, and so this can become now u plus 1 squared u plus 1 squared e. You can pull the e out, okay. Then we could just also say let y be equal to u plus 1, such that dy du is equals to 1, and so dy is equals to du, and then the limits would just remain the same, so that I now have a problem that is, so initially we have and this is y, so it becomes e, the limits remain, so we have something like that. And so this now becomes a half let me delete that so that we're a little bit clear on things. So this is the derivative of negative a half e y squared dy. Okay, so we have come to the point where we have y times the derivative with respect to y of negative a half e y squared, and then we can use integration by parts, where if we have integral of a function v and the derivative of function u, then we have uv minus u dv. And so our problem now becomes e negative a half y e y squared negative infinity positive infinity minus e over 2, and so we have another minus there, and we have y squared dy, and that is because now dv, since our v is y, so the derivative of y here becomes 1, and so we just have the constant e and a half showing up, and the negative and this minus interacts will become a positive. So we see that we have limit as y tends to positive infinity of negative e over 2 y squared. At positive infinity this tends to 0, same as y, because it's a square anyway, so same as here. So this also tends to 0, this tends to 0, plus e over 2 yeah. So essentially our problem now just becomes e over 2, the integral from y tends to negative infinity to positive infinity of negative y e to the y squared. And since we know this to be the Gaussian integral, our problem now is e over 2 times the square root of pi. And this is the answer. So in a way, if we are to now express our problem the way we knew it, we say from x tending negative infinity to x tending positive infinity of 3x squared x cubed plus 1 squared e to the minus x6 minus 2x cubed. The answer here is e over 2 times the square root of pi, and that happens to be our final answer. So until next time, I hope you have a great day ahead. Thank you.